Okay, 2022, paper 2, deferred, and question 3. The line L has this equation. The point P has coordinates k and k plus 8 over 2, where k is an element of R. Show that for all values of k, the point P lies on L. Now, any mention of a point being on a line means that if you fill it in, it should work, so to speak. So in other words, if I take the line that I've been given and I put P into that line, so K is going to go in the X position and then the K plus 8 over 2 is going to go in the Y position, it should make sense if indeed it is on the line, which we are very specifically told. Now, the 2's are going to cancel, so that make it a bit easier for us. Now, don't forget you have to apply the minus in not only to the k, but also to the 8. You're multiplying minus into the bracket. Now, straight away, I can see that this is going to work because I have k, minus 8, 8. So I end up with 0 is equal to 0, which is correct. So we know that P lies on L. Another line passes through the point P and the point A, which is minus 1, 1. Find the slope of the line AP in terms of K. So here I have a line AP. So we know that A is minus 1, 1, and we know that P is K plus 8 over 2. Now, it's supposed to be in terms of K, so we don't have to worry about finding out what K is. So all I do is my usual mention of slope, and I label x1, y1, x2, y2. I write down my slope formula, m is equal to y2 minus y1 all over x2 minus x1. So I do y2, which is k plus 8 over 2, minus y1 is 1 all over x2, which is k minus x1, which is minus 1. So it's kind of like minus, minus. So we're going to tidy all this up now to make it look a lot nicer. So my top line. So what I might do here is I might just write it separately. So I'm going to do minus 1 over 1. And then I'm going to divide it by, and that's obviously k plus 1. So I've just kind of split it up to try and make it a little bit more pleasant for us to use. So our common denominator is 2. The k plus 8 has the 2 already. So no change on bottom, no change on top. The next one, I change 1 to 2, so I double it. So I have to double the top, which is why the 1 is now at 2. And I'm going to ultimately divide by k plus 1. So I end up with k plus 6 over 2. Now, divided by k plus 1 over 1. Now, the reason I'm putting it over 1 is because now I want to use what I've been using since first year. How do I divide fractions? I change division to multiply and I invert the fraction that follows. So I end up with k plus 6 all over 2k plus 2. Now I can't simplify that down any further, and don't be tempted to try and cancel the 2 into the 6 or divide the 2 into the 6. That's all I can do. So that's the slope. I know it doesn't look very pleasant, it's nice to see a slope of 2 or whatever, but we are told to write it in terms of k, so we're done. Now, next part, the point B is at 3, 3. Find the value of k such that the angle BAP is 90. Okay, now BAP, so if you kind of think about, and we're told the angle's 90, so it must kind of look like BAP. In other words, because the angle's 90, it has to look like a right angle. A was what again? A is minus 1, 1. B, this is obviously not accurate to, this is not a coordinate diagram. This is a sketch. So I'm just putting in the coordinates. And P is, well, it doesn't really matter, but we have P from above. So it says, now we're trying to find the value of k. Now, because I know that they intersect at 90, hopefully you'd agree that perpendicular lines, which is what these are, should have slopes that are opposite in every way. In other words, opposite in sign and inverted. So let's remind ourselves that we do know the slope of AP. We've just found out what it is, k plus 6 over 2k plus 2. So what would the slope of AB have to be? Well, it would have to be inverted, and it would also have to be opposite sign. So if I invert it, it's 2k plus 2 over k plus 6. But I would also have to change the sign. So instead of being positive, I'd have to do negative. I'm going to leave the negative with the top line. It doesn't really matter, but you know, it just makes it a bit easier. If I'm doing negative and it's a fraction, leave the sign with the top. Now, you might say, well, that doesn't bring me any closer to finding k. Well, it does, in fact, because when I look at A and B, I do have coordinates that allow me to find the slope. So if I use the two yellow points to find the slope, can't I then let that equal to what I have over here representing the slope? So that's what I'm going to do. 3, 3, minus 1, 1, x1, y1, x2, y2. So that is the slope y2 minus y1 all over x2 minus x1. So that is y2, which is 1 minus y1, which is 3, all over x2 minus 1 minus x1, which is 3. So I'm finding that I have 1 minus 3 is minus 2, minus 1 minus 3 is minus 4. So the slope, in fact, is positive 1/2. So to finish the question, I'm going to allow the red, so the minus 2k minus 2. Notice I multiplied the minus into both parts, not just one, both. And I'm going to let it equal to what I now know the slope to be, which is 1/2. Cross multiply 2 times this equals to 1 times that. And now all I need to do is just multiply in. So what's that? Minus 4 is equal to k plus 6. Let's put it all on the one side. So that's 5k. That's minus 10. So k comes out to be minus 2. So that's my value for k, minus 2.